Step into the laboratory of Charles Proteus Steinmetz, the Wizard of Schenectady, and the bridge between theory and reality. This slide chronicles the journey of a persecuted immigrant who became the indispensable mind behind the modern power grid. While others fumbled with wires, Steinmetz used sophisticated mathematics, symbolized here by the phasor diagram and the angle theta, to master the volatile complexities of alternating current. He wasn't merely a technician. He was a visionary who saw the electrical grid as the foundation for a utopian future. By taming the invisible forces of magnetism and electricity with the stroke of a pen, Steinmetz transformed from a social outcast into the brilliant architect of our illuminated world. Our narrative shifts to a map of survival, tracing the improbable odyssey of Karl Steinmetz. It began in Breslau, where a brilliant mind in a fragile body challenged the status quo. After Proteus traded doctoral robes for the dangerous life of a socialist editor, he fled Bismarck's reach for Zurich. The ultimate gamble lay across the Atlantic. In 1889, Steinmetz stood at the gates of Ellis Island, penniless, ill, and marked for deportation due to his physical deformity. It took a friend's creative accounting regarding his bank account to slip him past the inspectors. From Prussian radical to American immigrant, this was the journey of defiance that brought the wizard to our shores. In the pantheon of electricity, two names usually dominate the stage, Edison and Tesla. But as this comparison reveals, the triumvirate of power was only complete with the arrival of Charles Steinmetz. While Edison championed direct current through physical prototyping and Tesla birthed the visionary sparks of AC through pure intuition, a critical gap remained. The world needed a mathematical architect. Steinmetz provided the rigorous complex algebra required to tame the chaotic behavior of alternating current. By translating Tesla's brilliance into predictable engineering formulas, he solved the mysteries of scaling and safety. Without his calculations, the electrical age would have remained a series of unmanageable experiments rather than the reliable national infrastructure we depend on today. Before 1892, designing electrical machinery was a costly game of trial and error. As alternating current pulsed, magnetic domains within transformer cores flipped back and forth, generating hysteresis, invisible internal friction that released destructive heat. Engineers were blind to these losses until their machines physically overheated. Enter Charles Steinmetz. Working in Yonkers, he quantified this invisible force with a groundbreaking mathematical law for pH. By introducing the Steinmetz coefficient, he allowed designers to predict efficiency and heat loss with pinpoint precision before construction began. This breakthrough tamed the volatility of AC, transforming it from a dangerous gamble into a safe, predictable foundation for the modern industrial world. Observe the transformation from chaos to clarity. Before Steinmetz, alternating current was a mathematical nightmare, a chaos of calculus, involving agonizing differential equations that limited engineering to a handful of elite physicists. In 1893, Steinmetz ignited a revolution with his paper on complex quantities. By introducing the J-operator and stationary complex phasors, he replaced the shifting sands of time-domain sinusoids with the steady ground of algebra. This mathematical shorthand didn't just simplify equations, it became the universal language of electrical engineering. By taming the alternating wave, Steinmetz democratized power, giving every engineer the tools to build the vast, interconnected grid that defines our modern world. To truly appreciate the wizard's impact, we must witness the profound paradigm shift he engineered. This comparison captures the world before Steinmetz, a chaotic era of grueling calculus, expensive trial and error prototyping, and massive energy waste from unpredictable heat loss. In those days, power was a prisoner of localized, isolated plants. The post-Steinmetz era changed everything. By replacing impossible differential equations with the elegance of complex algebra, he enabled precise mathematical prediction. Engineers could finally minimize energy waste before construction even began. This transition from guesswork to certainty was the catalyst for our modern reality, an interconnected, long-distance, high-voltage grid. Steinmetz didn't just build the machine, he gave us the master key to operate it at scale. As the 19th century closed, the heroic age of invention faced a reckoning. General Electric found itself outpaced by European rivals, and Steinmetz realized that the era of the lone, eccentric genius was over. his master stroke. Institutionalizing discovery itself. In 1900, from the humble confines of Steinmetz's barn, he birthed the General Electric Research Laboratory, the first of its kind in American industry. By uniting materials science, high-voltage testing, and commercial engineering under one roof, he transformed innovation from a chaotic spark into a disciplined, corporate engine. Steinmetz didn't just build better machines, he built the very framework of modern R&D, ensuring that the pursuit of a brighter future was no longer left to chance, but forged by design. In his final act of mastery, the wizard turned his gaze toward the heavens, or rather, 1,000,000 horsepower of man-made fury. As the electrical grid stretched across the continent, it faced a lethal threat: transients, those unpredictable, lightning-like surges that could vaporize equipment in a heartbeat. In 1921, Steinmetz became the forger of thunderbolts, constructing a massive generator to unleash high-voltage strikes within his laboratory. By shattering model villages and mapping the violent path of traveling waves, he decoded the physics of the surge. This research birthed the modern lightning arrestor, providing the essential armor that still shields our global power infrastructure. Steinmetz didn't just understand the power of the gods, he built the defenses to survive it. Beyond the sparks of the lab, we find the personal sanctuary of the wizard. At Camp Mohawk, Steinmetz famously traded his desk for a canoe, drifting on the river while drafting the complex equations that powered a nation. Yet, his most profound legacy wasn't mathematical, it was human. To avoid passing on his hereditary deformity, he chose not to marry, instead legally adopting his assistant, Joseph Haydn, and becoming a devoted grandfather within his chosen family. A man of brilliant eccentricities, his home was a crossroads for giants like Einstein and a haven for a menagerie of exotic pets. In this quiet refuge, he found the simple warmth of belonging, proving that even a titan of industry needs a place to call home. Our journey continues as the wizard steps out of the laboratory and into the heart of his community. In 1912, Charles Steinmetz embraced a new mantle as a civic leader in Schenectady, serving as president of the Board of Education. A lifelong socialist, he championed corporate socialism, believing that industrial efficiency should be harnessed for the public good. He applied engineering precision to social welfare, implementing radical reforms like free school meals, school nurses, and special education for immigrant children. Steinmetz proved that the ultimate goal of science and mathematics was not merely to power our machines, but to uplift the human condition and build a more equitable, engineered society for all. We reach the summit of the wizard's vision, the utopian synthesis. For Steinmetz, engineering was never just about hardware, it was a crusade for human emancipation. He viewed thermodynamic waste, like the hysteresis he famously conquered, as a mirror to the tragic waste of human potential spent in soul-crushing labor. In 1923, he issued a bold prophecy: by 2023, automation would reduce the essential workday to just 4 hours. He envisioned a world where the past, defined by drudgery, heat, and exhausting toil. The vision, defined by machines handling dull duties, freeing us to follow our natural bent. While our modern 40-hour weeks suggest he was a bit overeager with the timeline, his core philosophy remains: we tame the invisible forces of the universe to finally unlock the potential of the human spirit. We arrive at the blueprint of a legacy. Charles Proteus Steinmetz died in 1923, leaving behind over 200 patents and a world forever altered. He was the invisible architect of our modern reality, providing the mathematical structure for AC systems, lighting, and transmission networks that now span the globe. His life was fueled by a divine discontent, the belief that progress is born from a restless refusal to remain satisfied with the status quo. By taming the chaotic forces of alternating current, he didn't just invent machines, he designed the very skeleton of the future. We live today within the glowing, interconnected grid of his imagination, a final testament to the wizard who mathematically lit the world.